The point P, 0, 0.5, and part of the slope field given by dy dx is y squared cos squared x is shown below. Determine the equation of the solution curve through P in the form y equals f of x. I'm going to start up here. So separate and integrate. So integral of 1 over y squared dy is going to be equal to the integral of cos squared x dx. So this is going to give me negative 1 over y. And then we've got to think about the integral on the other side. So we're integrating an even power of cos squared. So we're going to use a cos 2a identity. And in this case, it will be the 2 cos squared a minus 1 version. So that's going to give me that cos squared a is equal to cos 2a plus 1 divided by 2. So here we're going to have the integral, let's put the half out here, of cos 2x plus 1 dx. So that's going to give me negative 1 over y is equal to a half of, integrate cos, we're going to get sine 2x divided by 2 plus x, and then there'll be some sort of constant here, which we'll worry about shortly. And so we have negative 1 over y is equal to sine 2x over 4 plus a half x plus a constant. So let's write that as negative 1 over y is equal to sine 2x plus 2x plus some new constant a, where a is equal to 4c. So we have 4c over 4, and we can put it on the top there and put that all over 4. Now we can flip the fraction upside down, and this one will be y over 1. And don't forget we've got this negative here. And flip the other fraction upside down, but what I'm going to do is put the negative onto this side. So it will be 4 over sine 2x plus 2x plus a. Now to work out that constant a, we have x is equal to 0, y is equal to 0.5. So 0.5 is equal to negative 4 over, and it was x equals 0, sine of 0 is 0, so that will be over a, and that would give us that a is equal to negative 8. So we're going to have y is negative 4 over sine 2x plus 2x, take away 8. Draw the solution curve through P on the slope field above. So that's the last part of the question. Draw the solution curve through P on the slope field above. Now, I'm going to do this, and then I think we'll have a look at this one on the calculator as well. So what appears to be happening here, if we go to the right from P, we can see the gradient seems to be going up like so, but then it's going to curve back over. It goes very flat, so it's very flat along here, and then when we get to here it starts to get steeper again, and it's going to head off the top of the graph over here. On this side it seems to be going down. It's quite shallow, and it appears that it might even asymptote there somewhere. So I think it looks something like that. Let us have a look and see what happens when we look at it on the calculator. So we're going to put in the new differential equation. So we're going to put in y squared, and put in a multiplication, I think, just to make sure, and times cos squared x. And I think what we're going to need to do is say, well, that is cos x, and square it outside. Remember, that's what cos squared x means. Hopefully that's all good. And let's go to the initial conditions, and we have 0 and 0.5 for the y. Okay, let's have a look. Let's get rid of the keyboard and let's graph it and see what happens here. Doesn't look too bad, does it? Looks fairly like what I've drawn, so I'd be reasonably happy with that.